Okay, so this lesson, you guys, again, we are going to be isolating variables and literal equations. So I'm just going to tell you right now, what you're going to see on the test is a lot like what we're going to see in the first couple examples, because that's what's going to be pretty relevant to us early on in the year. So if some of these are overwhelming or kind of tough, especially on the tail end, don't be so concerned about it. Uh, Focus more on understanding how to do really the first example. So again, we're going to be rewriting equations and formulas, isolating different variables. An equation has two or more variables is called a literal equation. You can rewrite and solve variables for other terms inside that literal equation. So for instance, what we're going to see a lot of this school year is the equation, or some like the equation 3y plus 4x is equal to 9. And we're going to have to isolate y early and often in this class. So I can't stress it enough. This is going to be kind of what you see on the test, is a couple of these, because as we go to graph lines, that's what it's going to look like. So first things first, if I want to isolate the variable y, what I need to fixate in on is kind of moving things away from it like I would if I were just solving for it, and I would treat this whole term like I know what it is. So if I want to move that whole term away from that 3y, I need to do the inverse operation, and I need to subtract it to the other side. Now you could write 9 minus 4x. What I'm going to tell you early is get in the habit of writing your x term first. So I'm going to write the negative 4x first, and then the positive 9. 9 minus 4x is not wrong. It's just for when we get to graphing lines, it's going to be written like this. The next thing we do, again, is understand that these are not like terms, so I can't put those together. I can't say 9 minus 4x is 5x or 5 or whatever. Those two aren't like terms, so they cannot be put together. So that means my next step in isolating my variable is simply dividing by 3. Now you can write it under the whole side, or sometimes students prefer to write it under each term individually. And this is almost the easier way to do it. Either way is fine as long as you understand you need to divide both terms. So now that I have my y isolated, again, negative 4/3 is going to give you a decimal. The fraction negative 4/3 can't be reduced. So I'm going to say just leave it at negative 4/3 x. 9 over 3 can be reduced. If I take 9 divided by 3, I get 3. So there's what it looks like when I solve that equation for the variable y. Again, we're going to see a lot of these. So if you need to rewatch anything or go back over anything slower, it's this one. So make sure you understand that. This one is similar. We're not going to have these on the test, but it wants us to isolate for x. Now this one's kind of tricky because I really can't isolate the x because it's on two terms, and these two are not like terms. One has just an x, the other one has an xz. So the first step I'm going to have to do essentially is reverse distribute. We're going to learn about what this is called later on. It's actually called factoring. But I'm going to take a factor of x off of both terms. Well, if I take a factor of x off of my first term, all that I'm left with is a 3. If I take a factor of x off of my second term, all that I'm left with is a 5z. Now that I have those two terms separate from the x, I can divide this to the other side because it's hooked by multiplication. I can take 3 plus 5z over to the other side, and that cancels out. So now my equation, as I solve it for x is equal to y over 3 plus 5z. So we'll talk about a couple more. I think one like this is a bonus on the test, so if you get really good at these and want to practice some on the homework, there is an opportunity for some bonus points on the test that looks similar to one of these. But really, on the chapter 1 test, there's going to be 2 like example 1, and the rest of it will be from the rest of the chapter. So take a moment, pause the video. I'm going to go through them kind of quick. Make sure you go back and watch it for the steps. So on number 1, again, make sure you have paused already. They're saying to isolate the blue variable. Well, that's the y, so I'm going to add the x to the other side. So then I have 3y is equal to x plus 9. Now again, remember, when I divide, I'm dividing every term. And then the value that's in front of that x is a 1. So you can write 1/3 x. X over 3 is also fine, but it should be plus 3. Okay, so it's 1/3 x plus 3. Number 2 is a little bit easier. So we have 2x plus or minus 2y equals 5. We're going to subtract our 2x to the other side. We have negative 2y is equal to negative 2x plus 5. Divide by negative 2 everywhere. Again, watch your signs, but y should equal 1x because it's a number divided by itself, minus, and again, you can just write minus 5 over 2. Okay, number 3, again, we're isolating the y variable. So the first step is to subtract the 8x to the other side. Again, those are not like terms, so I have negative 8x plus 20 is equal to 4y. And now I divide each term by 4. And I get negative 2x plus 5 is equal to y. And again, if you want to write that over here, that's fine too. Okay, numbers 4, 5, and 6, again, they're a little more work, but we're just going to use that reverse distribute step. So I'll do number 4 up here. We have y equals 5x minus 4x. Now, if we look at this one, instead of trying to factor 5 and 4 out, these are like terms. 5x minus 4x is just x. So I've officially isolated the x just because x is by itself and its coefficient is 1. Number 5 is not that easy. We can't just combine like terms. So we have 2x plus kx is equal to m. And I want to solve for x. So what I'm going to do is factor it off. And what's left inside the grouping symbols is 2 plus k is equal to m. And then I divide by my 2 plus k. And that's actually your answer there. So after that cancels off, your answer is m over 2 plus k. Okay, number 6. This one's probably the trickiest one. So we have 3 plus 5x minus kx equals y. So the first thing I need to do is I can't take a 3 off of, or excuse me, not a 3, but an x off of every term. I can only take an x off of these two terms. So I need to move this term to the other side. So I'm going to subtract that 3 over here. So I have 5x minus kx is equal to y minus 3. Now I can factor the x off and I get 5 minus k equals y minus 3. And I divide by my 5 minus k. And I've officially isolated my variable. So my answer is y minus 3 over 5 minus k. Now, you can do this isolating a variable in anything. Understand that. Again, like I said, I'm not going to spend too much time on these because I'm only going to really ask you how to do example 1, one that you will see like example 2 on the test as a bonus. Just for the sake of seeing this one, though, if I want to solve the surface area of a rectangular prism for the variable L here, here's what it would look like. And I'll probably stop here on this video just for the sake of time. So we rewrite the formula. And again, if I'm isolating the L, I want those terms to be the only ones over there. So I need to move this over there. So I have to subtract 2WH to the other side. So I have S minus 2WH is equal to 2LW plus 2LH. Now I can factor out an L, so I have S minus 2WH is equal to L times a quantity 2W plus 2H. And then I can divide by 2W plus 2H. So 2W plus 2H. Again, this is pretty advanced stuff, so I'm not going to put this on the chapter 1 test. We will definitely circle back to isolating variables and being able to do stuff like this. But for the sake of what's going on right now and what's relevant to us early, I'm going to make sure, again, I can't stress enough, make sure we know how to do example 1, and then go back and take a look at 1, 2, and 3, and the monitoring progress. I'm really going to look for those when I do the note check. Okay, good job, guys. Thank you. Have a great day.